Hi, my name is Philip Verplanke. I'm the CEO and founder of Aquahara. Today, I would like to clarify a few points about atmospheric water generators. The red color on this water scarcity map indicates the regions where we use up to 5 times more fresh water than nature can replenish by rain. Seawater desalination is a $20 billion business, growing almost 10% per year. But this is not the solution for all our water problems. It is only available in coastal regions and it actually causes a lot of environmental damage. To solve the water crisis, we need to implement many different solutions. We need to increase the water use efficiency in industry and agriculture. We need to recycle more wastewater. We need to restore watersheds, etc. Extracting water from air to replace the missing rain has been a dream for many engineers and inventors. Devices that extract water from air are called atmospheric water generators. The purpose of this presentation is to explain why conventional atmospheric water generators are not a solution and what the atmospheric water generator industry needs to do to move forward. Producing water with a conventional atmospheric water generator is the worst you can do for the environment. It is just an air conditioner that is used as an air dehumidifier. It wastes a lot of electricity to cool the air and condense the water. It does not work if the air is dry, and it also does not work if it is cold outside. If you operate it with grid electricity, you are effectively burning 1 liter of fossil fuel to produce 5 liters of water. 1 liter of water from a conventional atmospheric water generator causes 0.4 kilograms of CO2 emissions, 2 times more than mineral water in plastic bottles. Burning biomass instead of fossil fuel, like the winner of the Water Abundance X Prize is proposing, is not a viable solution in our opinion. If you add solar photovoltaic panels to conventional atmospheric water generators, this does not change the fact that their condensation method has low efficiency, such that they only produce 1 liter of water per square meter of photovoltaic panels per day. There are a few startups that are developing new types of atmospheric water generators that do not use a condensation but rather an absorption process. One of our competitors, indicated as C1 in this chart, and also Google X, have been working with a solid absorber that allows to extract water from the air in dry climate conditions, but with rather low efficiency. Our competitor C3 and we at Aquahara are using a liquid absorber, a salt solution, that allows us to increase efficiency. We produce 2 liters of water per square meter of solar collectors per day, and we use a combination of photovoltaic and thermal collectors to reduce energy costs. Here is the overview of the costs of different kinds of atmospheric water generators. Apart from the energy costs, the operating expenses of such systems are usually negligible. So what we did to make the costs comparable, we added the cost of external solar panels and batteries to the cost of conventional systems, such as those of our competitor C2, to make them comparable to the cost of newer atmospheric water generators that run on solar energy. The cost of water in this chart is calculated by dividing the capital expense, so the system investment, by the amortization time, which we set to 15 years for all systems, again to make them comparable. It turns out that conventional systems produce water at around 20 cents per liter, C1 at around 13 cents per liter. Google X published their systems would cost around 10 cents per liter if they would decide to move forward with it, which they didn't. C2 produces at around 7 cents per liter, and Aquahara's current pilot system in Morocco stands at 4 cents per liter. Our commercial systems should reach 2.5 cents per liter, and we want to develop a second generation system that should reach 1.2 cents per liter. It should be noted that currently people in West Africa pay around 6 cents per liter for pure water in plastic sachets. Water trucking usually costs around 2 cents per liter. and public water supply in Melbourne, Australia, for example, stands at 0.75 cents per litre. So as you can see, just like with any other new technology, we are on our way to reach cost levels that make this an attractive new option for water supply. How does the Aquahara system actually work? We use an industrial process known as liquid desiccant dehumidification and have systematically reduced the cost of all components and adapted it to use solar heat. Instead of cooling the air, we use a ventilator that blows the air through a structure that is soaked with a salty liquid that absorbs humidity. The salt solution is then pumped into a distillation unit, where it is heated and partially evaporated using solar energy. The vapor is then condensed to pure water. The salt solution is pumped back to the absorber in a closed cycle, and we use a heat exchanger to recover a part of the energy that was used to heat the liquid, to increase the efficiency. Aquahara has received a patent for an improvement of this process. In the condenser, we use the outside salt solution as a cooling liquid to avoid the cost of an additional cooling system. Let me show you our pilot system in Morocco that produces 200 liters of water per day using 100 square meters of solar collectors. This is our absorber. The black matrix is like a honeycomb structure. The salt solution flows through this structure from the top to the bottom, and on its way it interacts with the air that is blown through using a ventilator. This is our evaporator. It is like a hot shower of salty water that releases pure water vapor. Based on our pilot system in Morocco, we are now launching our first product generation. As I mentioned, it produces 200 liters of water per day using 100 square meters of solar collectors. It is completely off-grid, meaning it does not need any external power supply. It produces no noise because we do not use a compressor. It has a smaller collector area and higher efficiency than any other conventional or solar atmospheric water generator. And it produces water at 4 cents per liter in all seasons and all climates, whether hot or cold, humid or dry. Please be aware that the system cost and system performance data that are published by conventional atmospheric water generator manufacturers are not realistic. Here I am showing a cost calculation based on the power data from our competitor C2, which is the most efficient among all conventional atmospheric water generators. The cost of water strongly depends on what you're paying for your grid electricity. If you are paying 12 cents per kilowatt hour of electricity, your water will cost around 4.3 cents per liter, again considering 15 years of system amortization. You will also be emitting 0.4 kilograms of CO2 per liter of water, because in most countries, grid electricity is still driven by fossil fuels to a large extent. However, the 4.3 cents per liter mentioned before is totally unrealistic. First of all, that was based on performance data for 80% air humidity, which is actually very humid. In case air humidity is around 40%, the water production of a conventional device will be a factor of 2 lower. In addition, if you want to avoid burning 1 liter of fossil fuel to produce 5 liters of water, you need to consider the cost of adding solar photovoltaic modules and batteries to operate your device. The chart on the left shows how solar power changes during the course of a day between sunrise and sunset. If you want to operate the example system of our competitor C2 with 10 kilowatt of electrical power, you will need to install 10 kilowatt peak of solar panels and a battery of around 12.5 kilowatt hour storage capacity to operate this system for 6 hours per day at a constant power of 10 kilowatt on a completely sunny day. This means the device produces 4 times less water than published because it is operated 6 hours instead of 24 hours every day. This comes down to a cost of 7 cents per liter of water. You could buy more panels and bigger batteries, but that will only make your electricity more expensive. Now, if you consider the investment in an Aquahara system, our price already includes all the solar collectors and energy systems. Over a 15-year amortization time, water from an Aquahara system will effectively cost around 4 cents per liter, which is 40% lower than the cost of a C2 system operated with solar electricity. This is based on the cost of our current first-generation system. Like with all technology, the cost will go down as we manufacture a larger number of units. Aquahara is selling solar water production systems to house owners who do not have a connection to a public water network and who depend on their private water well. There are millions of such houses in the United States and many other countries. During summer, an increasing number of these households is forced to complement their water source by ordering water truck deliveries. We also sell our systems to corporations who want to become water positive next to becoming CO2 neutral. And when we sufficiently reduce the cost of our systems, we will also set up a pay-as-you-go business model, for example in West African countries, where people are now forced to pay 6 to 8 cents per liter for water sachets. I can imagine some of you may be skeptical, and you may wonder how solar atmospheric water generators will ever reach a cost of 1 cent per liter. To be clear, we're not there yet. The lowest cost for solar atmospheric water today is 4 cents per liter, as I've shown during this presentation. Part of the cost reduction will come through volume manufacturing, like with the photovoltaic industry 10 years ago. Part of it will also require further innovation into next generation systems. Let me take you through a few steps of calculation to show you how this works. To evaporate 1 liter of water from a salt solution or any other absorber, we and all our competitors are bound by physics. We need around 2,300 kilojoules, which is around 0.64 kilowatt hours of thermal energy. At the required temperature level, a solar thermal collector provides around 500 watts of useful heat per square meter, totaling around 3 kilowatt hours of thermal energy per day. At 65% thermal efficiency, which Aquahara systems have reached, this means 3 kilowatt hours divided by 0.64 kilowatt hours multiplied by 65% is around 3 liters of water per square meter of solar thermal collectors per day. In its 15-year lifetime in a sunny region, a solar collector will thus produce 3 times 365 multiplied by 15 is 16,425 liters of water. Assuming negligible maintenance, negligible operational costs, and without considering financing costs, this means a solar atmospheric water generator should cost $164 per square meter of solar thermal collectors to reach an effective cost of 1 cent per liter of water. Today's commercial flat-plate solar thermal collectors cost as little as $70 per square meter, which is only $0.14 per watt of installed heat power, which is, by the way, clearly cheaper than using solar electricity plus a compressor to produce the heat. This means solar atmospheric water generator manufacturers will need to learn how to build all their equipment at a cost of less than $94 per square meter of solar thermal collectors. Aquahara is working hard towards that goal. What does it mean if we have a renewable source of water at 1 cent per liter? This is still too expensive for irrigation and agriculture. It could, however, be used in very water-efficient greenhouses to produce vegetables and fruits. But the main purpose will be to supply water to communities and corporations. 1 cent per liter is 6 times cheaper than what people are paying for clean water in West Africa. It could replace water truck supply in many regions where groundwater is depleted. It could be an additional renewable source of residential water in dry, sunny regions, because 1 cent per liter is actually not far from what people are paying for public water supply in many cities around the world. And it can help as a decentralized source of pure water in regions where the public water network infrastructure is compromised. Thank you very much that you took the time to learn more about atmospheric water generators and how they are evolving from conventional devices that are expensive and very harmful to the environment towards new types of solar atmospheric water generators that may provide a solution that will eventually reach 1 cent per liter. If you have questions, do not hesitate to contact us. Bye bye for now.